Take off 2 nanofarads here. Just go back to 2. I had 4 there. And we'll be able to get on the 10 times scale here. Doesn't respond so well on the low. Maybe flip up to the times 10. 400, 600, 150, or 1500. Cuts off right about there. Oops. It's out just a hair. This is just a parallel bank here. When I get a 4, I get better response on the ELF frequencies. But with 2, I get better on the LF frequency. Pretty cool. It drives this MOT pretty good. Drives this guy really nice. I had some previous videos showing it. But for some reason the voltage is too high on that, and I think my jars are arcing to the table or something. They're shorting themselves out. I'm not really getting hardly any output on, hardly any induction into the secondary. With the MOT, there seems to be a good bit more current available to do that, and it's able to drive it a lot more. So this is just an audio signal generator running CW, and this is a 50 watt linear Class A power supply with the signal coming into a 12AX7 preamp tube. The other half of the tube is used to create a phase inverter. So we get two opposite signals, 180 degrees out of phase from each other. This is a rectifier tube, which gives me about 450 volts DC, runs through that choke, and then to the plates on these EL34 pentodes, which are driven in push-pull configuration. So this one gets the 0 degrees and that one gets the 180 degrees. And these white wires are directly off the anodes, and they're directly driving this non-standard output transformer. The center tap, this is the 240 volt winding, so 220s center tapped. B plus 450 volts is on the center tap, and then the two anodes go to the outer two. The 44 volt wrap coming off of there, I actually get about 250 volts off of it, and on the other side of that capacitor I'm using to drive the MOT. So this side of the mag wall isn't really doing much other than ringing, and this whole power output reaction doesn't take place unless these transformers are hooked up. So if I unhook this outer jumper, it won't actually have enough ring resonance here to push that transformer the way it's doing otherwise, but just enough to get it to arc over here. I had these in series in a distributed setup, but not with the MOT. I'll have to try that next, but doing pretty good otherwise. Get about almost a 1 inch arc off of that. I think I need more capacitance, but I've got to redo my banks. They have seen better days. That drives those 3 NSTs very well. I get a good inch, real strong inch arc off of the wire, but like I said, once it gets over here, it shorts out, so I got to fix all that. But I should see some improved output with those. If I don't blow these tubes up, I'm running them really low. This is my negative bias. And the more negative the bias supply is that feeds the control grids on these tubes, the less current that goes through them. So it's actually backed off really far. The bias is almost all the way down. I have the signal up here, but it'll pretty much work about 30% on negative 20 decibels. So it doesn't take a whole lot of input signal to drive the preamp. There is a little bit more of a distortion that happens when it's all the way up. There's some harmonics here coming out, but it's really interesting that this toroid that's designed for 60 hertz seems to do just fine, humming along all the way up to 7 kilohertz, and even up to 10 kilohertz. You can hear it coming in the transformer. The power output's really low at that point, so it's not quite enough to arc, or the gap has to be real tiny for it to do it. But progress. We have a truly analog, push-pull driven sine wave amplifier, and the inverted phase that comes out of both of these transformers shows up over here on the mag wall. So probing on the inner 2 taps of these transformers allows me, I can see both inverted phases, and on the other side of these transformers they get combined into one. So when I tap off of here, I'm actually getting not double the frequency per se, but double the voltage across each peak. So the highest peak and the opposite 180 degrees peak at the first quarter wave is literally double from what it would be if I was just driving this in the standard method. So I get a little extra voltage. So we're probably driving that with, it's hard to say, 400 or 500 volts AC probably. But the current is not so great, because it should be driving a lot stronger, obviously, but it may not be necessary. I need to figure out how I can get a little more current into this. So previously I couldn't try to drive this guy or even this guy straight off the tubes, and the 450 volts off the tubes just didn't really have no output. It was really bogging the tubes down. They burned out a set. They were heating up pretty good. But the use of this non-standard push-pull output transformer, power transformer as an output transformer, stepping the voltage down, gave me quite a bit more current over here, obviously, and that's just what was needed to drive these two coils, the MOT or this other coil. So it's pretty interesting. I'm interested to see what some higher capacitance will actually do in terms of frequency. So I can really see nodal points on this. Let me zoom out. On this secondary, and probably 3/4 of the way up, right about here, I can draw a really strong arc about 1/2 of an inch to 3/4 of an inch off of it, a real bright purple strong arc, and then it diminishes up above there. So I know my length is too long. I really need to chop this thing off, like right here. Take off about 200-300 wraps, and that'll probably be the perfect length for the wavelength. Frequency changes with the load, obviously, so that MOT brings the operating frequency way down, the point where the highest voltage output for the given frequency, that is. Without the transformer, with this transformer, excuse me, it was most ideal at 7 kilohertz actually. So I could crank the audio generator all the way up to 7, and that would give me the most output from it, the point where I can actually hear the electrostatic corona leaking off of there, the hissing, and just enough to where it's right at the breakdown threshold. So it's only breaking down at the peaks. And it's interesting. So you get in the standard Tesla coil setup where you have a parallel capacitance discharging, which is what this is. Now, you're not operating at any special frequency based on the spark gap. You're really not. You're only operating at 60 hertz, and with some harmonics depending on your circuit, you get some harmonic tones in there as well as distortion, but it's still only operating at the fundamental frequency of 60 hertz. It can only fire 120 times a second at each peak, positive and negative. But when you can increase the incident frequency, when the right frequency can be provided at the beginning to drive the circuit, it's a whole different ballgame. Because now, even though core saturation you would think is affecting that, it still is responding at a much higher frequency than designed. Iron core transformers are supposed to take a shit after 100 hertz or more, right? This shouldn't be vibrating, yet it is. This is why the mag amp works. With a capacitor in series, normally, there's none here now, but normally this will go into this self-oscillation when I kick the 22 volt winding here, which is the kicker wrap. It'll start oscillating by itself, not so efficiently, but it is doing it, and that ringing causes enhanced voltage output from the secondaries on it. So by running the audio amp into it, I can produce the same kind of vibrating at my incident frequency instead of the line noise 60 hertz frequency that I'm not used to using. So it's beneficial because now I can work with a much higher frequency to start with, and obviously reduce my need for capacitance and better tune to the wavelength that the vertical height of this coil is set to, which is obviously too high. This generator only goes up to, was supposed to go up to 200K, but honestly, I think the tubes give out around 40K or so. They just don't get any, you obviously can't hear the sound anymore. It's beyond the audible range, but the tubes here seem to give out, or at least the transformer can't vibrate. I don't quite know, but probing it, I don't see any signal beyond that point over here. So I think that the transformer either can't vibrate or is oversaturated at that point, or just the tubes aren't designed for it. These are audio tubes for tube amplifiers. They're not really designed for megahertz operation. That said, I have some other tubes that are designed for much higher frequency, but could operate on lower frequencies, but they're designed for MOT level voltage. So the next step may be to use a driver stage, an additional power, this become the driver stage, what was originally the power amp stage, and then use that to actually drive the control grids of my GU81M tubes, the 750 watt pentodes, and I could drive those control grids with these anodes, give it the 450 volts, and so forth. I need a negative bias circuit for that, probably around negative 150 volts, something crazy. These only run on about negative 25 to negative 40 volts bias, just to put it right at that avalanche threshold so that the input signal from the preamp and the phase inverter are right on the line and holds that signal wherever it needs to be. So these tubes are really cool because they can work. They don't have to have a real high voltage to on the grids to actually cause the cathode electrons to be attracted towards the plate. With the negative bias, you actually lower the reference point of the signal down to the negative 25 to negative 40 volts, and that allows the same fluctuation or the same valving still happens with a negative voltage reference signal. So it's a cool thing about tubes. You can't do that with you can't do this with transistors. You want square waves, you use transistors, but true analog sinusoidal varying signal is reproduced 100% from the tubes. There's no digital processing going on here, no transistors or anything. It's just straight tubes and capacitors and transformers, which is ideal for driving audio amplification systems, and especially the high voltage step up here. A square wave has more harmonics and whatnot. I can flip the audio generator over to square wave, and it doesn't quite have as much power output. I can still get it to arc, within reason, and adjusting the frequency and get some effects out of it. And I even get a good arc up here, but you can physically hear the difference between the square wave and the sine wave through that. So it's very cool. Now we can produce high voltage at LF, technically low frequency audible range, which should be more than plenty, that we can stay under 20 kilohertz. But now we have a quest of finding the right capacitance orientation for this 50-ish microhenry primary coil, which probably needs to be bigger. I got me some new wire, and that I may expand this, make it taller. I got enough wire to probably do a little more than double what's here. So that would probably work out pretty good. Then I can get a primarily up to here, and I bet that shifts the nodal quarter wave peak to probably towards the top of the physical coil itself, so I don't have to cut it. So we'll see what happens. Either that, or I'll use it for this if I ever get around to wrapping it one of these days. Tube amps. Throw them transistors away. Play with tubes. That's all, folks.